Hi, my name is Kathleen. For my research project, I studied emerging approaches to container scheduling. For cloud-based software to run efficiently, containers must be scheduled to minimize make span, or the time it takes to schedule and execute a set of containers, as well as overall power consumption. The scope of my research included single criteria schedulers, multi-criteria schedulers, and AI-based approaches. I did not consider other approaches to scheduling, such as dynamic or opportunistic approaches. Containers and scheduling are covered in Chapter 5 of the Somerville textbook. Containers came into use in the mid-2000s after major cloud companies started using them to manage larger server clusters. When Docker was released in 2013, it allowed containers to communicate with each other. This meant containers could be used to implement complex distributed systems. After this advancement, cloud developers needed a way to manage the interactions between containers. Kubernetes, released in 2015, performed this function and can be used with any container management system, including Docker. Before we discuss container scheduling, it's important to understand what a container is. A container is a unit of software that packages code and dependencies together so an application can be run in a different computing environment quickly. In the top right graphic, you can see containers running inside different nodes within a cluster. Each container is made up of layers of the file system images, from the operating system to the top-level application. In a large distributed system, hundreds or even thousands of containers will be running at different times and in different sequences. So you can see in the bottom left graphic, Kubernetes employs a scheduling algorithm to assign containers to different nodes. In general, the algorithm assigns each node a score based on some function which is designed to optimize speed and power consumption. The node with the best score receives the container. In single criteria approaches, the function that assigns node scores continues only one or two aspects, such as the amount of resources currently available in the node. In multi-criteria approaches, the function considers many different aspects and combines these aspects into a single rating. AI-based approaches are similar to multi-criteria approaches in that multiple criteria are considered, but an AI algorithm determines the weights different criteria are assigned and calculates the overall risk, instead of it being a directly implemented algorithm or function. After learning about these different approaches to scheduling, I believe that single criteria scheduling is probably too simplistic for most modern applications, although it is simple to implement, which is a benefit. I think multi-criteria and AI-based scheduling both have a role to play for different kinds of applications. An AI-based approach might require more overhead, but will likely provide a more accurate final rank for each node if done properly. A high-demand application that needs to truly maximize efficiency might choose an AI-based approach over a non-AI multi-criteria approach, but this might not be necessary for all applications. In completing this project, I found it interesting that AI approaches have been applied relatively recently to container scheduling. Because of this, and based on my research, I believe there's a lot of room for more research and statistical studies comparing the performance of different approaches. I enjoyed learning more about this emerging field of study. Thank you for your time.